السلام عليكم ورحمة الله وبركاته. دكتور نضال الصالحي, Faculty of Business, University of Petra. Today we will continue chapter 4 with the forecasting methods. I just would like to remind you what we have discussed last meeting. Last meeting we started with the quantitative methods of the time series. And we said that there are 4 methods for time series. Number 1 was the naive approach, moving averages, and we discussed 2 types of moving averages, weighted moving averages and the non-weighted moving averages, and of course the exponential smoothing. Today we will discuss the 4th method of time series, which is the trend projection. We call it also regression analysis. It's a kind of regression analysis. Of course, our solution today will depend on the regression equation, or we call it the estimation equation, which is, as you can see, y hat, as you can see here, y hat is equal to a plus bx. Now y hat, sometimes we can say y not, okay, it's the same. Y hat is the forecasted value. If you want to forecast sales, so it will be sales. A is the y-intercept, or it is the value of y when x is equal to 0, and of course the b, it's the slope of the line, and x is the independent variable. There is a very important note here. Please, our topic today is very easy if you focus and concentrate with me. Please, I want you to understand that x here is the independent variable, and in the time series, in trend projection, it's always, as you can see in red here, it's always the passage of time. Okay, it's always time, the passage of time. Why I am saying that? Because later on we will discuss the second model, which is the associative model or associative forecasting. Now, if you understand the trend projection, you will apply the same calculation and the same equation to the next model. Okay, so please concentrate with me. Now, let's start. So y hat, as we said, it's our forecasted value. If it's sales, it's sales. If it's demand, then we are talking about demand. Okay, and x, the independent variable, I will repeat again, and it is the passage of time. Now, we call this method also, which is the trend projection, we call it the least squares method mathematically. Okay, now this figure just to show you what we are talking about. Now, the blue line, the trend line, it's our equation. Y hat is equal to a plus bx. Now, as you can see, on the x-axis, we have the time variable, periods. Let's say it's years, for example, year 1, year 2, year 3, year 4, and so on. Now, of course, the x-axis is the independent variable, as we agreed. Now, the y-axis is the dependent variable, which is the y hat here in our example. And of course, sometimes it is demand or sales. Okay, this is just to show you the stars, for example, are the actual values. Now, the forecasted values will be all on the trend line, on the blue line here. Okay, now the distance between the actual value here represented by stars, the vertical distance between the actual value and the line, we call it deviation, which we were calling it sometimes, we call it sometimes forecasting error. Okay, so let's go further and try to see our equations, or the equations that we need in order to calculate the forecasted value for a sales or demand or whatever. Now, this is our equation again, regression equation. Now, the most important thing that you have to calculate only for 2 values. You as a student, you have to calculate for the value of A and the value of B. And here you always have to start, this is a note, you always have to start with calculating the value of B. because if you have B, then it is easy to calculate A, because as you can see, A is equal to y bar, sorry, minus B multiplied by X bar. So B is here. So you have to calculate for B first in order to be able to substitute the value of B in the equation of A. Okay, so we'll use those two these two formulas, which is the B equation and the A equation, in order to calculate for the value of A and B. If you calculate for A and B, the value of X, of course, will be given. Then you don't have any problem to calculate for sales or demand or any other forecasted values. Let's see example. Let's start with this easy example. The demand for electric power at New York Edison over the past 7 years, so this is the historical data again, is shown in the following table. Okay, we will see now the table. What we need here, or the company needs, is to forecast the demand for next year. So next year period will be 8. So we know already the value of X. Because we have 7 periods, we want to forecast next year, and next year will be period number 8. So the value of X in our equation is known already. So let's look at the given. This is the given in the question, as you can see here. This is historical data from year 1 to year 7, historical data, and we need to forecast sales or demand for year 8. And of course, these are the electric power demand here are actual values, of course, because it is passed already. So let's see how we will use historical data, okay, the values of X and Y here, in order to calculate for A and B, and then we can predict or forecast our sales, okay, for of course our demand of electricity for next year. Let's start the solution using our formulas. Now, before we use our formula, as you can see here, we have to calculate for X bar. And you know, all of you know that X bar, it means the average, the mean of the values of X, okay, or the average value of X, of the X's values. Now, as you can see here, we will take the sum of all X's, which is 28, the sum of all Y values, which is 692. Then we can solve for the average value of X, which is X bar. It will be the sum of X, which is 28, divided by the number of periods, and the number of your periods is 7, as I told you. Okay, so we will have an X bar, or an average value of X's of 4. We have also the Y bar as 692, which is the sum of Y's divided by 7, which is equal to 98.86. Just a reminder, as I told you last meeting, you know, this square, it's not a square, it's the sign of summation, but in the PowerPoint it will appear to you as a rectangular or as a square. Okay, let's continue here. And of course, we have the other values here, the sum of X squared, the sum of X multiplied by Y. It's easy. We have just to substitute those values, okay, that we have calculated here easily, in order to find the value of B. And remember, we have always to start calculating for the value of B, because it will be substituted here when we are looking for the value of A. Okay, so the value of B will be 10.54. Okay, now it's easy for us to calculate for the value of A, which is equal to the Y bar minus B multiplied by X bar. Okay, we know already the Y bar, 98.86, minus, we know already also the value of B, which is 10.54, multiply by X bar, which is 4. So we will have the value of A, which is 56.70. Now let's go back to our regression equation, and we have to substitute the value of A and B. And of course, as you can see, A is 56.70 plus B, which is 10.54, multiplied by X. Now we have to forecast the sales or demand of electricity for next period. And as I told you, X here, which is the independent variable in the trend projection, it's always time. So X here, as I told you before, it's given by period number 8. So we will substitute now, instead of X, we will substitute the value of X, which is 8, in order to solve for the demand, the forecasted demand for next year, which is year number 8. As you can see here, we substitute 8 instead of X. Then our demand for next year will be 141 megawatts as demand of electricity for that residential area. Now, if we will go, okay, now we can see here, we can see it graphically, just to show you the idea. Now, as we said, we forecasted the value or the demand for next year, which is period number 8. We can also forecast for next year if we want to, which will be 9. Yani we have, if we substitute 9 here, okay, instead of X, then we will have also the demand for next year, if you wish to do that, or the company wish to know the forecasted demand for next year. Okay, let's go now to the second model, because what we all of the methods that we have discussed, it is related to the time series methods, okay, or model. Now the second model is the associative or causal forecasting model, and as I said, look at the note here in red. We apply this technique just as we did in the time series example. The example that we just have finished now, we will use, everything will be the same calculation, the same equation, even the value of A and B will use the same formulas, except I want you to understand that X here is not time. It is something else except time. Let's look at that. Okay, let's try to understand what I am saying. You see the same formula. We don't want to repeat ourselves. Y hat is equal to A plus BX. Y hat is the forecasted value again. A is the y-intercept, or it is the value of y when x is equal to 0, and B is the slope of the line, and X here is independent variable also, but it's not always time. It's not time at all. It's anything except time. Let's see our example. Our example here will prove that you don't have to learn new things. You have just to use the same equations as the time, as the trend projection, except I told you for the value of X. Nodal's Construction, or Nodal Construction Company, renovates old homes in West Bloomfield, Michigan. Over time, the company has found that its dollar volume of renovation work is dependent on the West Bloomfield area payroll. So payroll here is X. It is the independent variable. And of course, Y is the sales or the demand. Now, management wants to establish a mathematical relationship, of course, in terms of regression analysis, which is the same regression equation, y hat is equal to A plus BX. Now, they want the company here, as you can see, the required of the question, what is the estimated sales for Nodal if the local chamber of commerce predicts that the West Bloomfield area payroll next year will be 6 billion. So if X next year is 6 billion, what will be our sales? So we know already the value of X, which is not time, as you said, it's payroll. Okay, so let's start solving the question using the same formulas. Okay, we don't have to repeat ourselves, except here that you have to take note that here you can see area payroll is X, okay, which is the second column. The first column is Y. How many periods is given as historical data here? 6 periods. Okay, let's have a better look at it. Here it's given when X was previously, for example, when X was previously 1 billion as a barrel, okay, our sales at that time as a company, it was 2 million. When it was 3 billion, it was 3 million, and so on. Now what we have to calculate, the same thing, the sum of X, okay, the summation of X, Y values, sorry, the summation of X values in order to calculate for X bar, which is the average values, what is the average value of the X values, okay, and we have to calculate also for Y bar, which is the mean. The X bar will be 3 and the Y bar will be 2.5, or the average Y will be 2.5. Now we can solve for the value of B using the same formula, the sum of xy minus n multiplied by X bar multiplied by Y bar divided by the summation of X square minus n multiplied by X bar square. Okay, the same formula. We will have the value of B as 0.25. We can now calculate for A, which is 1.75. We have to substitute now the value of B and the value of A in our equation, as you can see. Okay, so our equation will be our sales, which is the Y hat, will be equal to 1.75 if you want to, plus 0.25 multiplied by barrel, which is here the X. It's not time anymore. Here we have to substitute, of course, 6 billion. Why? Because it's given in our question. Let's look at our graph here. Okay, now if you can see, those points are the actual values, and of course the forecasted value will be on the trend line, on the line itself. As you can see also, we can now substitute 6 billion. If barrel next year is estimated to be 6 billion, then substitute here 6. Okay, we know already the value of A and the value of B. Then we will have our estimate, okay, or our forecasted sales for next year will be 3,250,000. Okay, so you see, it's the same computation, the same calculation that we applied in the trend projection. Let's go now, or let's see it in our graph. If you notice that if our barrel is 6 billion, then we have a forecasted or estimated sales or predicted sales of 3.25 millions, which is 3,250,000. Now we call this a point estimate. How about if we need to look for an interval estimate? Now we have to calculate for new things, for something new, which we call standard error of the estimate, okay, which is the SEE. So instead of a point estimate here, 3,250,000, we can make an interval, because we cannot always be precise. Yani we want to estimate our sales for next year from, as here, 2, okay, from 2 as an interval. That's why we have to calculate for something, we call it standard error of the estimate. You can see the formula here. Okay, students, please take note. This formula, you don't have to know it. We don't want to use this formula. There is another formula to calculate for the standard error of the estimate, which is easier, which is this one, the next formula. Yes, here you see, for computation, this equation is easier to use. So please use this equation, not the previous equation, in order to calculate for the standard error of the estimate. Okay, let's go back to our example and calculate the standard error of the estimate, so that it will help us to have an interval, as you can see here, as interval estimate of our demand or sales for next year. Let's apply it. Of course, we will use the same the same numbers that we have calculated for a while ago. You see, this formula is easier. The sum of y square, we know it already, minus a multiplied by the sum of y. It's already there in our questions. In our question, it's given. We know already b, and the sum of xy, we know it already. So we can apply, only substitute those numbers, and we will have a standard error of estimate. Sometimes we call it the SEE, and sometimes they call it SXYX, but it's the same as the SEE will be 306 thousandths. 306,000. This means that our sales estimate for next year will be 3 million, if we go back to our number, 250,000 plus or minus 306 thousandths. Okay, that's why we have already arranged. If we will take the minus, we will have a certain number, then we will take it as a plus, then we will have a certain number. Then we can forecast now our sales for next year as a range, as an interval value instead of a point estimate. Okay, now let's go to what we call correlation. Now correlation, of course, it will measure correlation R. Okay, correlation, or we call it the coefficient of correlation, as you can see here, coefficient of correlation R. Now what is R? R, it measures the relationship. Okay, it measures the strength and direction of the relationship between two variables. Now the coefficient of correlation R, it always ranges from -1 to 1. It means that R is always greater than or equal to -1, or less than or equal to 1. So if we will apply the correlation coefficient also for our example, by the way, no, let's go back to the equation. Okay, here. This is the formula of R, how to calculate for R. Please listen to me. Students, please, all of you, listen to me. Now, the correlation coefficient R here, only this formula, you are not required to memorize this formula. All other formulas, you have to memorize it, but this formula, you don't have to memorize it, because the value of R will be given ready for you. Okay, only this formula. I repeat, okay, everything else you have to know it, you have to memorize it. Only this formula you are not required to memorize it. So if we will calculate for R, which is the correlation coefficient, in our example, the same example, okay, if we go back, before that, as I told you, now as you can see here, if R is equal to +1, as you can see here to the right, then we have a perfect positive correlation. If it's exactly 1, imagine it's a perfect relationship. On the other hand, on the left side, if R, or the coefficient of correlation, is equal exactly to -1, then we have a negative, we have a perfect also, a perfect correlation, but it is a perfect negative correlation. And of course, as you can see here, sometimes we have moderate correlation, like here, it almost ranges from -40% to 60%. The same also to the right hand, if it's on the positive side, it's also moderate from 40 to 60. Now, from 0 to almost -20 or +20, it will be a no correlation, or a very little correlation, which we cannot depend on it in order to forecast our values. Let's apply the correlation coefficient for our example, the same example exactly. You see, everything is given, so you have to apply the formula of R. Then we will have R as 0.901, which means that the relationship between the demand in our example, okay, and the sales is what? Or between the barrel, sorry, the relationship between the barrel and the sales for our company is 90.1%. 90.1%, which is a very strong relationship, and it's a positive one. It means when X, I mean the barrel, increase, also our sales will increase. Okay, there is another concept that you have to know, which is the coefficient of determination R squared. Now what you have to do for R square, only you have to square your R. So if we square our R, which is the correlation coefficient, we will have the coefficient of determination, which is R square. In our example, it's 81%, which means, now this is what is important for R square. And by the way, R square always ranges from 0 to 1. Why from 0 to 1? Because it is squared already. That's why it does not have a negative value. Now, what's the meaning of 81%? The meaning of 81% that the barrel as X was able to explain the changes in our sales by 81%. Imagine, it's a very high percent. That's why management of the nodal company or the nodal construction company should take care, okay, of the barrel as an independent variable and use it in order to forecast their sales. And it will help them a lot, of course, in strategic planning and in planning in general. Now, the last topic is the easiest topic. It's only a formula that you have to apply it. We call it tracking signal. Then the tracking signal, it will measure how well the forecast is predicting actual values, to predict actual values. Now, we have to take note here that good tracking signal has always low values. It means the lower the value of the tracking signal, okay, the better and the more, let's say, the more precise and accurate our forecast is. Now, we have another note here that I want you guys to know it, which is if the forecast is always greater than or less than the actual values, I mean all the time, then the forecast is said to be biased. Yani this is a good note to take in order to be as an indicator for you as a forecaster. If your forecasted value is always greater all the time or less than also all the time than the actual values, then there is a bias in your forecast. Anyway, what we care about to show you the formula. Now look, these are not two formulas, it's one formula. Now, the tracking signal is easily or simply equal to cumulative error divided by the mean absolute deviation, which is the MAD. And of course, the MAD, we have discussed that before. Now, this one is only an explanation of the formula. Okay, the second formula is it's only just, detailing your main formula. So just know that tracking signal is equal to cumulative error divided by the MAD, and we'll see now a very simple example. But before that, I want to tell you something that managers use in practice before they calculate for the tracking signal in order to know that their forecast is a good one or not, okay, or it is accepted or not accepted. What they do usually, each company will have an upper control limit and a lower control limit, okay, and in the middle, of course, it will be a zero MAD. Now, before the zero, it will be a negative lower control limit, or above the zero MADs, it will be a positive upper control limit. Now, as we can see, for example, here, if the value of our tracking signal is above this line, okay, then we can say that signal exceeds limit, which means that our forecast is not acceptable. Okay, now, suppose, for example, that here we have a positive 4 and in the lower control limit we have a negative 4. So if the value will be 4.5, let's say positive, then it exceeds our upper control limit, then the forecast will not be accepted. Let's take a very simple example just to explain further the meaning of tracking signal. I want you in this slide, please listen to me and focus. On this slide, I need you to concentrate on 1, 2, 3, on the fourth column from the left, which is the error. Look at the error, because you know already how to calculate for the errors. It's actual value minus forecasted value. Okay, what is new for you is the cumulative error, and we need, as you know, to calculate the cumulative error. let's please concentrate with me. The error here is 90 minus 100 is minus 10, isn't it? So we have cumulative error minus 10. Now let's continue. Now minus 10, we need it as a cumulative one. Plus minus 5 is minus 15. Plus 15, 0. Plus minus 10, it's minus 10. Plus 15, it's plus 5. Now plus 30, so our total cumulative error is 35. Okay, and of course you know how to calculate for the MAD. Okay, our MAD will be the sum of forecast error divided by n, which is the number of periods. So we have the total of our forecast error, as you can see in this column, is 85 divided by the number of periods, which is 6. Then we will have a MAD of 14.2. Now we know already the cumulative errors, which is 35 divided by the MAD, which is 14.2. Then we will have a 2.5 MADs. Now, as I told you, the experts, they will have an upper limit and lower limit. For example, if their upper limit is 4 and minus 4, then this number of MADs here, 2.5, will be within the accepted range. Okay, that means that the forecast will be accurate. And this ends our class for today. I would like to thank you, and I would just want to remind you that please read the material first. After that, try to listen to this video, this explanation. If you don't understand anything, please ask questions during the class time or at any time you want on the blackboard, but it's much better that the question will be on the class time. So see you again next Monday. Okay, and I will remind you this video will help you a lot. Please listen to it carefully. Thank you very much, and I hope that I will see you always fine. Thank you very much.